So then the challenge is, how do you build a secure and compliant cloud platform, but one that is able to run on any cloud provider? And let me go a little bit more into details about why this is a challenge. So for those of you that are at least as old as I am, let me remind you, why exactly do we have cloud platforms to begin with? Why do application developers love them? Why does everybody adopt them so much? Well, it's pretty much because infrastructure is very complex and is very messy. I have here a picture that I have taken when I was younger. And yeah, nobody really wants to deal with cables and fiber optics and replacing hard drives anymore. You want to outsource that as much as possible. And think about how difficult it is to deal with a rather simple compliance requirements, a business continuity requirement, such as tolerate extreme weather. So without a proper cloud platform, you would pretty much have to install 2 servers in some colocation facilities, and you would need to make sure that these colocation facilities are far enough so that they don't get impacted by the same outage, such as a power outage. But then again, you want them close enough so that, for example, you can do something like synchronous replication, or anyway, so that they kind of feel like the same data center. Then you need to install and configure operating system. You need to configure primary and secondary database. You need to make sure that you set up synchronous replication. You need to install the application runtime. Then you need to deal with, how do I make sure that ingress traffic goes to the healthy data center? And often you would end up with something like BGP Anycast that requires very deep integration with your network provider. I'm pretty sure that I forgot some steps, but anyway, just think about, you have to go through 6 steps before you can finally focus on what you care most about and where your magic sauce is really located, your application. So you have to go through 6 steps before you can finally work on your application and make it tolerate extreme weather. Now, in contrast, if you have a supporting cloud platform, say, for example, AWS RDS, then it's as simple as, you just go to the web interface, or you edit a certain Boolean flag in your CloudFormation template, and you just click on multi-AZ deployment, done. Everything else happens behind the scenes. VMs are being configured in the right availability zones. DNS entries are configured properly in order to point to the masters. Other DNS entries are configured correctly in order to point to the secondaries. And everything just works with failover and everything out of the box. So then you can immediately focus on your application. Now, if you're thinking about it, what actually happens today, or what is the state of today's platform? Well, on the positive side, they allow you to focus on your magic sauce, which is pushing high impact application features faster. They reduce the amount of effort. You need to worry less about managing and setting up platform services. You need to worry a lot less about the infrastructure that is below you. However, all of these services are built essentially on top of a proprietary control plane, so which means that you lose control. You no longer own the whole tech stack. And then if you need to move to a different tech stack or to a different provider, then you basically need to port all your effort to a new proprietary control plane. Now, if you have adopted open source services, this, of course, the effort is somewhat smaller, but believe me, it's still quite a huge integration effort. And it's not the kind of discussion that you want to have, like, are you supporting this or supporting this? Well, we're not really sure. That's not really the conversation that sells very well if you're in front of a customer whose data protection needs are high. So ideally, you would like a platform that should give you both focus and also control of your whole tech stack.